time, I'd like to introduce both of our speakers, starting with the second speaker who's coming later. Her name is Sandy, I'm trying to get this right. Sandy Krishnamurthy. She has over 20 years experience and she's an engineer at Actian. And we have our first speaker of the night, Emma McGrattan. She is the SVP of engineering at Actian, and she has over 25 years of experience, originally joining in 1992 with Ingress. Please welcome Emma.
All right, so who's here for the drum? Okay. And who's here for the lovely street food? Okay. So if someone's going to help with the drum, you need to fill out one of these cards and we'll do a drawing. And at the end of the evening, you need to be here to win it. So, you've probably never heard of Actian Vector. You've probably never heard of Actian. So I thought what I'd start with is to talk. What's it some of our customers, right? So Actian is a company that started life with the original Ingress Corporation back in the early 80s. So I actually started working with Ingress at Dublin in 1992 and been through a couple of acquisitions and divestitures since then. So we changed our name from Ingress to Actian in 2011. And the reason we changed it was we wanted to be more than just a database company. So we went out and we did a bunch of acquisitions around data integration, around data analytics, and kind of built out a part of the portfolio that enables us to go from integration into operational databases and then through the analytics, so kind of running the gamut there. And we've a bunch of really exciting customers, and the one I'm going to pick on here is Revenue. You've probably never heard of them. This is the Irish equivalent of the IRS. And they're my favorite customer because they don't pay tax in Ireland, so they can be my favorite customer. And what they use our software for is pretty much everything they do. So all of their, you're filing your tax returns, all that information is stored within our Actian Ingress product. Where they use Actian Vector is for doing analysis on late payment of taxes. So they can kind of figure out the patterns of who's not going to pay their taxes on time. And they do some crazy stuff, like they look at social networks and they will figure out that if your declared income is, let's say, $20,000 and you just bought a Humvee, they'll come ask you some questions. So they actually do this, like looking through social networks, and they're really clever. So it's not just your income, but they might look at maybe your sister-in-law on Facebook is posting photographs of the entire family up in Reykjavik for Christmas or something, and they're tracking all of these things. So they're very sneaky, very clever. But the first time I went to them to talk about Actian Vector, I thought they'd make a great early adopter of the technology. So we brought the technology forward in 2010 with the early adopter program. And I said to them, this stuff is incredibly fast. You've got to trust me on that. So at the time we knew they had a report that ran in Ingress that took 13 hours. And I said, I'll bet you I can take that report from 13 hours to a minute. Right? So we had this bet. And it was for really pint of Guinness and a nice lunch. And I was pretty sure it was going to win, right? So we run the report and it comes back in seconds, right? So it's way less than a minute. And they thought I cheated, right? I think that. So they took a look at the results that the report produced and they said, those are the right results, but do you know what the results should be? So they changed some parameters in the query to make sure we had cached results so we weren't doing any tricks on them, and consistently it was coming back in sub 1 minute. So I thought I'd not just won a launch, but I won a new customer for a brand new product, and it was kind of a marquee name in Europe. But they said, look, it doesn't matter that takes 1 minute now, because we run that report on a Saturday night, and on a Monday morning, we have printed copies of the report to all of our collections pages that go around the country collecting delinquent taxes. So they're like, we're not interested in Vector. So I managed to convince them that if they could do a more real-time information on the delinquent taxpayer, because typically what will happen is that they'll want to perform, and if you're going to take your cracker, you haven't paid your taxes, and if that was the farmer would say, I paid yesterday, I went to the head office of the local tax office, and I paid my taxes there. And they're not able to kind of counter that with anything, so they need to find out whether or not the taxes were paid. So by being able to access the information in real time, it was going to really change that whole tax collection process. There's no wasted visits across the country, and there's no argument as to whether or not payments were being made or processed. And so they wound up buying it, and they're a great success story for us today, because they have a massive economy in Ireland. It's a booming economy, and with Brexit, I think it's going to grow only more. And so they're a good success story for us, and they love to talk about their use of our technology. And we've other logos on here, and if you visit our website, you'll see a lot more of what we do. So Actian Vector is one of a family of products. And what we're here to talk about tonight is Actian Vector in Hadoop. And the reason we chose Actian Vector in Hadoop is because there's a ton of interest in Hadoop right now, and not so much interest in super fast analytics databases. And another product that we have in the Actian Vector product family is a product that we call Actian X. It's a brilliant name. I'm joking about that. It's a terrible product name. Try and Google X. It's impossible. But what happened was I was heading out on vacation, and they kept renaming this new product we were releasing. So I put Actian X in my PowerPoint, thinking that that's a placeholder, and the marketing guys will put whatever they decide upon in its place. And they thought X was really cool, because it's a crossover technology that provides for OLTP, which is transactional database usage, as well as an analytics engine with X100. So that's Actian X, our crossover database. Also known as HTAP, which stands for Hybrid Transactional and Analytics Processing. And it's a term that you hear from Gartner. And the guys at Forrester calls it a translytic database, so it's transactional and analytics database. So, because you never, has anyone heard of Actian Vector before tonight? Somebody guessed X100. Oh, wow, there's somebody here that knows our technology. I guess kind of obvious, isn't it? All right, so Actian Vector, we released this product as a very small company, right? We're about 350 employees, and we thought to make a big splash that we would release a TBC benchmark. So TBC is the Transaction Processing Performance Council. It's basically an industry body that defines benchmarks that all of the database, hardware, software, operating system, and analytics tools players participate in. And the TBC-H is a benchmark for measuring ad hoc and decision support query performance. And what you'll see here is that in running this benchmark, which is audited and completely independent of us, the Actian Vector performance throughput at 2.1 million is twice the throughput of our nearest competitor, which is SQL Server 2016, and almost 10 times faster than Sybase IQ. Now, every time I get asked why isn't Oracle on here, and that's because Oracle's number is below Sybase IQ, so they don't qualify for the top results. Vertica was an HPE product, and our result there was actually published in conjunction with HPE. And they were releasing a new server, and they wanted to sit at the top of this table with their new server, and they worked with us to release the highest number. So Microsoft's going to have a hard time catching us, and we're incredibly fast. But what does it mean in the real world, right? So in the real world, I skipped ahead, and I'll get back to that in a minute. In the real world, it means that if you're running reports or you're running dashboards, that you're able to work with your entire data set. You don't have to work off, maybe a sampling. Oftentimes we go into, particularly in financial services where they have a lot of data volumes, and they're running queries that are based upon samples of 10 or 20% of the data. The other thing that we focused on with Actian Vector is to be standards compliant. And what that means is that if you have an estate of dashboards and analytics applications and reports and so on, and they'll just run against Actian Vector. So if you were previously using something terrible like SQL Server, Oracle, Teradata, Vertica, whatever it may be, and all of that investment that you've made in your analytics technologies will just work. So it's available for Windows and Linux, and later on you're going to see a demonstration of it running on Windows. And we've also produced a version for Hadoop that we're going to get to in a minute. So the X100 engine is what powers Actian Vector, and it's incredibly fast. And the reason why it's so fast can be kind of called out in these 6 secret ingredients. They're not a secret anymore because I'm telling the world a little about them. But the first is we use vector processing. Does anyone know what vector processing is? Well, that would be a good question for a class. Anybody? Come on. Oh, yeah? Moving head over here? Okay. Okay. So you can think of a vector as an array of data, right? And modern CPUs have vector processing built into them. And the reason they have it was maybe initially for graphics and for gamers, that they wanted to be able to take full advantage of the CPU's capability to perform operations on arrays of values at a time instead of on single key values. And the brains behind Vector and the database decided that that's perfect for database technologies, right? So in a typical database, and the more traditional databases, which is pretty much all of our competition, if you were doing something like giving everybody who works for the government a 20% pay increase, right, you would go through this massive employee database, you'd go to the salary column, and you'd multiply that by 1.2 a record at a time. When you're using vectors, you'd actually perform that operation on 1,000 salary entries at one time. And so you're going to be significantly faster than records at a time. So everything we do within the database, whether it's calculating an average, calculating means, we're doing it on batches of vectors, and that makes our product incredibly fast. And it's the reason for the name. Much better reason for a name than simply heading out on vacation just before release. The next thing is that we use the chip cache as the database cache.
Does it work on you running GPUs?
We don't actually have a GPU database today, and we run on standard CPUs.
But if you run on standard CPUs that you don't have by multiple cores, right?
So the question was, do we run on GPUs? And my answer to that was we don't. And the subsequent comment was that by not running in GPUs, you're limited by the number of cores in the system, and you're absolutely right. And that's why we moved to Hadoop as a scale-out solution. So we can scale up on a single server to all of the cores that are available, and we're seeing servers now with over 200 cores, but to scale it out, we do run on a Hadoop cluster. GPU databases have a place, and they're incredibly fast. For kind of a streaming analytics solution, we're much better suited for that deeper analysis that would happen past the streaming analysis.
So the standard product of yours is only can parallelize the number of cores, and if it's not for Hadoop in particular, then it's number of cores on the specific machine.
Yeah, so the question was, or I guess it's a comment again, and it's a valid comment, and we're obviously going to be limited by the number of available cores in terms of the level of parallelism that we can provide, and that's true. But when we're operating as quickly as we can get a lot of things done very quickly. But you're absolutely right, yes, there is a limit on the laws of physics apply, right? So absolutely,
it's probably 16.
If you have a 16-core machine, yes. Typically, we're running on servers, so we're talking about 200 cores, up to 200 cores. I would guess our average customer is running somewhere between 30 and 50 cores. But we have like some pretty significant customers, and the horsepower that we provide.
It's pretty expensive. The machine with 200 cores.
It is pretty expensive, but it's also commodity hardware, right? So you go onto Dell or Cisco or IBM's website and you choose it. You don't have to go to Teradata and buy a specialized hardware environment, but on standard hardware. You can go to HP website and buy a 200 core machine.
It's not commodity.
Well, it's not commodity, right? But it's not. Yeah. We'll move on. We can talk later on. And in fact, Sandy works at a GPU database company.
And I have to tell you that it's very well suited for very, very large volumes of data. But typically, enterprises do mixed workloads. I was in the company that was actually having a map team, it's called mapping, and they have a map GPU-based database. When you're loading data into a GPU, you're still engaging the CPU. So the number of cores you have for the GPU is simply less. Most of the vendors out there are 4 main vendors out there. No one uses the GPU for loading. GPUs are great as long as you load the data into the GPU memory and keep querying it again and again. Once you start doing ad hoc queries, it has to go back to disk again. It's not efficient. So it's got ways to go. So if you have the same data and you're querying it again and again, having so many cores makes sense. While I have seen that it's really not, I know a lot of CPU-based databases are actually doing much better than GPU-based databases, and vector definitely is.
Okay, it depends on what
We'll have a conversation about that. You'll have a conversation with Sandy about that later. Okay. You're from Informatica, or is All right, so moving back. We call ourselves second generation columnar, and if you think about analytics, right, typically what you're doing is you're performing operations on columns of data. You want to get maximum discount that you've given and the average price that was paid. You're typically looking at individual columns of data. So it makes sense for analytic databases to store the data in that way. Now, we call ourselves second generation columnar because one of the challenges that columnar databases have, because they're storing data in columns, is if you want to update a row of data, they have a really hard time figuring out how exactly that cascades through the system. So we actually figured out a piece of patented technology called positional delta trees, which if you're interested in exactly how it was done, and you can Google that. But basically what we figured out is, how do you support updates on a running system without impacting the performance of the running queries? And it's quite an achievement, right? A lot of databases will have a read store where all your read queries are running against it, and in the background they have a write store where the updates are happening, and then they switch the two over so that your queries are running against the latest version of the data. But we don't have to have that overhead. It's quite a clever idea. This is a capability that we brought to Hadoop as well. So anybody who's using Hadoop will be aware that one of the drawbacks on Hadoop is that the HDFS file system, which is the distributed file system that sits under Hadoop, was designed for data to be written once and then read ever after. And this whole idea of having to make corrections to the data or delete individual records wasn't part of the design paradigm. And it's a drawback for many people in adopting Hadoop. That's something that we addressed with Vector in Hadoop, and it's quite unique. And the only other technology that provides support for updates on HDFS is Hive. And they do it in a way that's not efficient, and we'll talk about that in a minute. And then Cloudera addressed this issue by introducing another file system called Kudu. And Kudu borrows many of the ideas from our technology, which are out there. We publish everything we do as academic research. But updates on Hadoop is a real challenge, and it's one that we've addressed. And it's the reason that we say that we provide enterprise data warehousing capabilities on Hadoop. And the next thing is we use very smart compression algorithms. So the way I like to think of this is, if you shrink the data down as small as it possibly can, it's going to move through the system pretty quickly, right? And so what we look at is, disks are really inexpensive. So when we're compressing data, it's not to minimize its footprint on disk, but rather to come up with an efficient algorithm that will allow us to compress it quickly and decompress it really quickly. And so we're looking at CPU utilization and making sure that we've optimized for fast decompression within the CPU. But we do get a 6-to-1 compression ratio, so it's still pretty good. But the data size isn't our main focus. And we wanted to keep things really simple because we like simplicity, right? So you don't have to have a very difficult complex indexing scheme over your Hadoop data, and you don't have to bring on additional technologies like AtScale and Jethro data to provide performance on Hadoop. Because as we're writing the data on Hadoop, and this is true of Windows and Linux as well, we automatically create an index on that data. So when you're writing blocks of data to disk, we keep track of the minimum and the maximum value that's stored in that block. And then when we're solving queries, we know which of the blocks are going to have data that's pertinent to solving that query, and we're reporting data. Come on in. So these automatic indexes allow us to solve queries really quickly, and also allow us to ignore data that's not going to be part of solving that query. And the last thing, which you probably don't particularly like, is that it's designed for multi-core parallelism, right? So it's designed to take full advantage of all the cores available in the system. And if you have experience with Hadoop, you'll know that many of the SQL and Hadoop query engines were designed as parts that are single-threaded, so they can take advantage of all of the available resources. And we've designed this thing so that we will parallelize the query to the nth degree, to the point where you get diminishing returns on that parallelization. Because you reach a point where it takes more time to break down the work, execute it, and pull the results back together again than it's worth. So these are the 6 things that make Vector as fast as it is, and they're all part of what we call the X100 engine. So in June of 2014, we released a product that's called Vector in Hadoop. And what the Vector in Hadoop technology does is it takes this X100 engine that I've just described, the 6 characteristics of, and it runs this X100 engine on a set of data nodes in Hadoop. each X100 engine is responsible for its own partition of the data. So what happens is you, at the top here in the lovely turquoise, you have a client application. And that's any application that speaks SQL or JDBC, ODBC, any of those languages that enable connectivity through to a database. That issues a SQL query that comes in, and we make sure that that SQL query makes sense, that it's written in the standard SQL language. And we then optimize the query to come up with a query execution plan that tells us what's the best way of executing this particular query. And then we turn that execution plan into what we call X100 algebra, and that's the language that the X100 engine speaks. When that X100 algebra comes into the X100 engine, and it's running in the master node, the master worker architecture, it rewrites that query in a distributed manner, and then it passes pieces of the query over to the X100 execution engine. It's going to be responsible for running that part of the query on the data that it's allocated. So you partition the data across all of the nodes. And who's using Hadoop here? Anybody? Okay, so not as many as I thought. Okay. We do some clever things. So there's not a ton of Hadoop knowledge in the room, but the HDFS file system is designed for a commodity, low-cost big data platform. Right? So the idea was that some of us are old enough to remember the 90s, right? And what happened with Linux and the fact that Linux was a low-cost alternative to proprietary Unixes and into some very expensive Windows servers. And there was a place for that. People were tired of paying huge fees for software that they thought was pretty much commoditized at that point in time. And with Hadoop, the idea is that the cost of using something like Teradata or Exadata to save data that might be over-meter data, or it might be social networks or social graphs, that's not considered the crown jewels of your organization. That cost was just too high. And they wanted kind of a second tier data storage platform, and that's how Hadoop was born. So HDFS is the file system that sits under Hadoop. It's designed to be distributed. One of the clever things about the file system is it, by default, replicates blocks. So as you're writing a block of data to the HDFS file system, by default, it writes 3 copies of that data. And what we did with Vector and Hadoop, we said, well, if we're going to be writing copies of that data to other nodes within the Hadoop cluster, why wouldn't we place those replicas where it's going to benefit us? So I was joining 2 tables, and they were naturally co-located on a disk. Why wouldn't I just make sure that one of the block replicas was co-located? Because the file system's guaranteeing that that's an exact replica of where the data is written elsewhere. And then we're able to avoid having to communicate between nodes to solve complex queries. And that's what kills distributed databases, right? It's when you have to transfer data between nodes to solve the queries, performance just is limited by the network bandwidth between the nodes, and it's a real challenge. So the Vector and Hadoop architecture is very simple. Everything we do, and we like it to be simple. And all of the characteristics that I mentioned previously, like being able to support updates while queries are running against the system, and being able to, by default, build all of these indexes on the data so that you don't have to, makes it really easy. You basically install it, load your data, generate statistics on the data or not, and then run your queries against it. So all of your existing analytics infrastructure will just work against it. And since there's not a lot of Hadoop knowledge in the room, I don't know how believable this is, but basically we built Vector in Hadoop to provide the capabilities that one expects in a traditional enterprise data warehouse, but on the Hadoop platform, so on what is considered a commodity platform. And everything we do within our product is designed for speed. So we have a very simple, very fast alternative to these solutions, and we're built at a Hadoop price point. Is there a question? So the question was, this is incredible. You're all the way to the right on the cutting edge, and you're all the way to the top on the industrial strength. How did you get there? And I drew the graph. So that's the truth. But I don't think anybody would disagree with me. So our competition that we'll typically find in Hadoop is either people that came to Hadoop with expectations that were set by the traditional enterprise data warehouses, or people that have really struggled in getting Hive and Pala or Drill to work on Hadoop. So if we talk to somebody that's using one of these solutions and they've put at-scale or Jethro data sitting on top of it, we know that we're going to win there because they're struggling to get the performance they need with the tools they're trying to use on Hadoop, and that's perfect, that's their sweet spot. So it's enterprise capabilities on a very attractive price point. This is a bit of an eye chart. Can anybody read this value?
1.341.
All right, so what we've done here is, and I apologize, it's going to be hard for you to read it. The benchmark I mentioned earlier, that was our industry standard benchmark, and it's comprised of 22 queries. And what we did was we ran that benchmark against our technology and against the popular SQL and Hadoop solutions, Hawk, Spark SQL, and Pala and Hive. And what's represented in the graph here is how many times faster vector H is, vector H is short for vector in Hadoop, is than those competitors. And what you'll see on this graph here is that it's drawn on a logarithmic scale. So we're up to 1,000 times faster. So somebody answered that question earlier, how much faster is vector in Hadoop than in Pala? And it's up to 1,000 times faster. And the reason I asked if you could read these numbers here is, so vector in Hadoop completed that first query in 1.34 seconds. If we look at Impala, it took it 585 seconds, right? Which is close to 10 minutes to run that same query, right? Hive took 490 seconds. So we're hundreds of times faster than the competition. And to me, because I'm really impatient, if I was waiting for a report in 1 second, that's totally fine. If I'm waiting 10 minutes, I'm going to go with my gut feel and not wait for the results of that report, right? So this makes a difference to people that are trying to use existing tools against Hadoop and who don't want to build a new infrastructure. Part of the benchmark requires that you delete 1 day's worth of data. So we're storing 3 days worth, 3 years worth of data. You delete 1 day and you insert a new day. So it's a typical enterprise data warehouse paradigm where you age out a day's worth of data and bring in the latest day. And Hive and Vector and Hadoop were the only two solutions that could perform that delete and insert. And after performing the updates, the performance of Hive dropped to, previously we had 490 seconds, now it's at 608 seconds, right? So across the 22 queries, the performance of Hive dropped by almost 40%, it's about 138% of what it was previously. And for anyone interested in learning more about this particular benchmark and the performance comparisons we performed, there is on our website a paper called the Sigma paper, because this was prepared for a database conference called Sigma. But to put it in perspective, right, because the numbers are hard to read, and for Hive to run all of those queries took over 2 hours. For Impala, it took almost 2 hours. For Spark SQL, it took over an hour, and for Vector and Hadoop, it was under a minute, right? So, blazingly fast technology. If you're looking at Hadoop, you'd be crazy not to take a look at it. And I'll come on site with Sandy, and we'll do this dog and pony show for people in your organization. So, one of our first customers for the Vector and Hadoop technology was a large bank in the UK, and they're a bank that grew through acquisition in the last decade. And when a lot of the banks started collapsing, and there was opportunities to go out on the buying spree, and this bank wound up with 30 different risk applications. And what they needed to do was to produce reports mandated by the European Union that showed that they hadn't exposed their risk over the course of the business day. And they had a 1 hour window in which to produce the reports across the 30 different risk applications. So to begin with, they said, we can't run very discrete reports and try and figure out how do we sort that data and figure it out. So instead they said, let's move all of this data onto Hadoop and run the reports on there. So they set us these goals for performance. So it was like, we had to be able to load a day's worth of risk data, which is 2 billion risk data points. Is anyone here in risk? Okay, cool. 2 billion, I see. Oh, sounds like allergy season. 2 billion risk data points had to be loaded in a 6-hour window. We had to do a full day aggregation in 30 seconds, filtered aggregation on 1 million data points in less than 15 seconds. Had to prove that we could store, wow, that's a medical. Store 80 days worth of data, which at 2 billion risk data points per day is 160 billion rows. And they said, look, they could go on another major buying spree, so they could grow up to 10 billion rows. And we had to, I need to remember attention. But if they grew up to 10 billion rows per data, we could still handle that. And they wanted to do drill up and drill down in less than 2 seconds. And we blew them away, right? So I won't go through these results at the time, but what you'll see is that we bested their expectations quite considerably, and they were incredibly excited with the technology. So textbook scalability, and
so just starting off the data points.
So the data points are risk data points, so they're not particularly large, right? So the records in risk are typically kind of small records. I don't remember the exact width of a row for this, but not terribly wide rows. Okay, so that was like a real-world example, and it was kind of validation for this bank that having a Hadoop strategy made sense for them. There's a lot of people out there that are contemplating Hadoop and they don't know whether or not it's going to meet their needs. I will tell you, don't waste your time with Hive or Impala. Just, go and take a look at Vector and Hadoop. And we have an evaluation version of this you can get for free, and it will work with you to make sure you're successful. I don't know how interested you are in security, but we built the product from the ground up to be secure. So all of the security features that you expect to find in a traditional enterprise data warehouse or a traditional relational database are built in, right? So we start with user authentication, that is that we confirm that the user is who they say they are, and we support a multitude of authentication mechanisms, including PAM. So if you're using pluggable authentication mechanisms, they will all just work with it. Discretionary access control means that you can control what a user can and can't access, to the point where you could say, for this set of records, this user has update capability, for everything else it's read-only. Role separation means that the database administrator can be kept out of sensitive data. So maybe you've got personnel data that you don't want the database administrator to see who got what bonuses or pay increases, and that you can use role separation to keep the DBA out. And we provide support for security auditing and security alarms. So that means that you've got to keep track of who's doing what within the database. We provide a set of SQL tables, they're SQL addressable tables, and that you can write your audit reports against to see who's doing what. And you can set up a security alarm. So if you were using discretionary access control to keep me out, because I'm really nosy, of sensitive information, let's say I'm looking at hospital patient records, the fact that I attempted to access that record could trigger an alarm. And you could send an email saying, this is something that you need to look at. It will have kept them out, but the fact that I attempted is something that you should look into. And then encryption is really important, right? With everything that's going on with cyber these days, I think we're all very conscious of encryption. So we provide support for data at rest encryption. So you can, as you're defining your tables, you can say which columns you want to encrypt. We also run on encrypted file systems. In Hadoop, you've got the concept of encrypted zones on HDFS, and we support that. And then data in motion, you can encrypt all of it. So that, for many people, has been a concern about Hadoop. And because we come from the more traditional relational database world, or enterprise data warehouse world, and these features are built in. So this isn't running projects like Apache Ranger and Sentry and Knox. These are built into Vector and Hadoop, and also available on our Windows and Linux product. Anybody in the room using Spark? Oh, great. Okay, how are you using Spark? Which is really cool. Okay, so we're using Spark for a number of things. We've got a Spark loader, which allows us to bring data in from any source that Spark can access. We can do incredibly fast loading. In fact, because Spark parallelizes the loading. And we also support all the traditional ETL tools for loading data. And we're seeing a lot of interest in this because it's blindingly fast. So we can load the data here into Vector. And we also have a Spark connector, this is part of the demo that you're going to see from Sandy, that enables us to make any data source that Vector can access an external table. So what that means is if you've decided that you're going to land data in Parquet files on S3, but you want to join that with your incredibly fast Vector data, we can do that using this Spark connector. And we also provide support for building applications in technologies like Spark SQL and R and Scala, again using that same Spark connector. And then the standard, which is SQL-based tools like Tableau and Qlik and so on. So a really interesting and extensive architecture that basically allows you to pull data from pretty much any source into the database for fast processing. If you don't want super fast processing and you prefer that you want the data to reside natively where it's generated, so maybe it's landed on S3, and we also have the ability to pull that in, and then whatever database, whichever development technology you decide to use, that will all just work with Vector. So here I've listed out some of our partners. We get asked all the time, which partners do you have at Actian, and which tools can I use with the database. Pretty much anything that uses JDBC or ODBC will just work with the database out of the box. But we have data integration partners for getting data into the system as quickly as we can. And I mentioned earlier that we have our own data integration technologies, and those are obviously our preferred methods, but some of these others are out there and we work with them. And then on the business intelligence and analysis tools, all of the major vendors here, so we're using Power BI, and some aren't listed like OBIE. We work with all of them, and I just was limited in space on the slide. So that's it for my part of the presentation. At this point, I'm going to turn it over to Sandy for a live demonstration.
Thank you, Emma. And as promised, while we are switching laptops and setting up, I'm going to give away yet more of these Volkswagen Beetle bugs. Not Beetle bugs, vans. Hang on. I'm losing it. Whoever catches it. What?
Today is not up for the giveaway?
Yes, I have a point. Let me get there. Yes, we are giving away this drone right after the main presentation and QA. So in order to win this drone, you do have to put your your business card in this container, fishbowl thingy. If you don't have one, there are cards here as well as in the back table to fill out with your information. You do need to fill it out completely in order to win the drone. But we are going to give this very beautiful, big, heavy, 12-pound drone away. Feel free to come up now while I'm doing the trivia and put your card in. Let me grab some Volkswagens. Okay, let's give away some more VW buses. I didn't expect everyone to come up at the same time. Okay, let's try a question. Real-time updates are supported by which two SQL and Hadoop solutions? Spark is not actually right.
JDBC.
No.
I said in the first.
Hive. Yes, it's a Hive. Yes. And what's the other one?
Vector.
Yes. That was the obvious one. Okay. To insert data into Active Vector, you upload the data and then do what? Trick question. Trick question. Nothing. Who said nothing? Okay, let's do a number question. How big is the largest Hadoop cluster in the world? In numbers, number of nodes. Very big. Who said that? Forever. You gotta give your extra ones out to whoever doesn't have them. 70,000 is way too large. Much less than that.
200.
Bigger than 200. Less than 10,000, greater than 5,000. I'm sorry, less than 5,000. 2,000. Greater than 2,000.
3,000.
Higher than 3,000. Higher than 4,000. Less than 5,000. 4,500. Someone around you. Okay, who runs that 4,500 node? What?
NASA.
No? Not Google. Run the right track. NASA? Not NASA?
Yahoo.
Yahoo's right. You gotta give it to someone around you. Okay, what does ACID stand for in computer terms? Yes. Okay. Hadoop is named after what? Yes, an elephant. What kind of elephant? Sorry, a what elephant? It's not a toy. It's not a toy elephant. Right. We'll get it to someone around you. A toy elephant. I am running out of questions. I think I may have run out of questions.
Any questions that from the first part of the presentation? Yeah.
Are you guys in the cloud?
Are we in the cloud? Great question. This man over here is working with Amazon to get into the cloud today or tomorrow. So we have an AMI that we have had accepted by Amazon, and we're expecting to get the link to say it's been published. We're waiting on tender hooks here because we.
If they look at the Amazon AWS Marketplace and search for Actian, hopefully within the next day or two it'll be published.
So that's a free version, and we give away the free version good for 250 gigs of data. and you can spin it up in a couple of clicks and get going with vectors. And Nick asked me to point out the fact that we don't just run on Hadoop, we're on Windows and Linux as well. And oftentimes we displace products like SQL Server and Oracle. And we see a lot of that actually, but they're not designed for analytics. They have a hard time performing analytics. So with Oracle, we come in at least 10 times faster at 1/10 the price. And SQL Server, we've measured it up to 6 to 8 times faster. But they're more price competitive, so we're about 60% of the price of SQL Server.
What's your average size of the database?
The average size of the database is a great question, because it really depends upon the source data that you're analyzing. So we have a lot of customers that are a sub-terabyte, and because they're dealing with ERP and CRM systems that don't generate a ton of data. And then we have a lot of new media customers that have much larger data volumes. And on a single server, we'll support up to about 10 terabytes of data, and up to 2,000 concurrent users.
So how does the database compare to MySQL?
That's a great question, and I have a slide in a minute. When we're going through the Q&A, I'll show you performance. So we're actually faster than MemSQL, and we also, MemSQL starts falling apart when the amount of data exceeds the available limit. They have problems with that. We don't have that same problem. We have some very fast, so we've got some very clever algorithms that figure out what's going to get evicted from the cache and what should stay in. So we support that. MemSQL also has a problem with updates in a running system. We're trying to update the data while it's supporting running queries. MemSQL doesn't handle that very gracefully. We have a solution that addresses that challenge.
So I'm basically Sandhya. I'm a sales engineer with Actian. I've been with the company for about 1.5 months now, fairly new. From Emma's presentation, I'm sure it's very, very clear that Vector is very, very suitable for analytics. It's a great analytics database. It's very, very fast. What I wanted to show you today is powering like newer or more up-to-date analytics like machine learning or AI or deep learning. How do you do that with Vector? So what we are recommending is using Vector as your backend database, which is very, very fast. Spark happens to be a very, very popular tool that a lot of data scientists basically prefer because it's got a rich set of APIs, right? And I did see some hands go up when we spoke about Spark. I'm sure some of you are using Spark. And you can basically say how efficient it is. I think the best thing about Spark is your ability to bring in different types of data into a data frame or into the Spark environment and actually run advanced analytics because it's got a rich set of APIs other than your machine learning libraries, and it really powers the next stage analytics. So what I'm going to do today is I'm going to actually show you Vector in action with the Vector, the Spark connector. So just wanted to kind of talk about the configuration here. So I'm using the Spark connector available as of 5.0. This is supported on Linux, but what I'm going to show you is how you can run this on Windows. 5.1, it's going to be available, it's going to be GA. A lot of times when I tell data scientists I'm using Windows, they're like, you're not serious about your job. But that's the reason I basically chose Windows, because I wanted to show you the power of Vector on an operating system that's really not preferred by data scientists. So the configuration machine I used here is basically a Windows 10 VM, 64 GB RAM, 16 cores, and the Spark connector that I'm using is V1.1. If you ever want to try this out, just let us know and we can get a version available for you. And then I'm using the Scala API. I don't know how popular it is. A lot of people use Python, but I use Scala for this. I'm fairly new to machine learning, so I'm sure you'll be able to point out some better ways to do things. But just bear with me, the demo is pretty eye-popping here. What I did was I used the flights data that comes as part of our database. It's in the sample database. So the goal is to create the correlation between year, quarter, and day or month to the departure delays. So I basically took that data and I'm using it a very simple machine library function in Scala to basically show you the correlation between these three features and the departure delays. So just summarizing the steps here, right? What I do is I'm going to show you how I'm going to actually create that table in Vector. And then what I'm going to do is I'm going to power off some of the ML library friendly RDDs, create a RDD of label points in Spark. And then I'm going to run the Scala script right in front of you so that you actually see for yourself the way it works. So number one thing I'm going to do here is I'm going to drop the table that I'm creating on vector. And the reason why I made this a little complicated is because I wanted to show you how vector performs when you do these complex calculations. Actually, this query is a little more simplistic than what I'm actually going to be doing. I actually take two sets of data because correlation really likes data to be in a certain format. It expects 0 to be there in the column that you're calculating correlation for. So I had to eliminate some of the values, I had to change some of the values. I'm going to do that right in front of you. So let me just skip out of this. Hopefully I'm able to get into the So I've just opened like the command line window and I'm actually connecting to a vector here. As you can see, my previous run ran in 5.45 seconds. I deliberately left this on so that you can see it running just in case things crash like it did before. So I'm going to drop the table and recreate it right in front of you. Fairly quick. Again, I'm going to run this query that's actually doing the union all, and then slicing and dicing the data. I'm going to get the timing stream so that you see for yourself how fast it is. So as you can see, it's actually getting back 163 million rows, and it did that whole thing, created that table for you in 5.23 seconds approximately. So once we have done that, I'm just going to invoke Spark. The connector is actually available and it is very, very easy to use. All you do is download it, set some path libraries into your Hadoop and Spark installed, and then you start the Spark shell. Of course, depending on the amount of data that you're actually bringing back and into Spark, you want to make sure that you have enough memory for your install. I use like 25 gigs and 8 gigs of memory for the executor. And then what I'm doing is I'm just importing all the machine library imports into Spark. And then I am getting in a JDBC connector into the Spark environment. And then people who have been running Spark, I'm sure this is very, very familiar. And a lot of people may argue that there's a prettier way of doing it. I just wanted to kind of detail all the steps so it's very clear for people who have not worked on Spark to understand. So I'm just creating like a temporary object definition in Spark. And then this last line here is actually pulling in that entire 163 million into the Spark environment. And then this is all related to the correlation calculation. Some of these things you will learn is that machine learning libraries require a certain format. They need a labeled point RDD with the label and the features. It's called the lib-svm format. You can look this up. You have to get the data to that particular format, which is exactly what I'm doing here. Once I do that, I'm actually running the correlation function. The actual statistical function is highlighted right here. It's statistics.corr, and I'm comparing the label and the features, feeding that in. And my result is going to look like this. It says that the correlation between the year and the departure delays is about 0.13. The quarter is actually negative, meaning there's actually negative correlation, and the day of the month is about 0.0006. There's a little bit of 101 here. Bottom line, anything negative means there's like a downhill correlation. 0 means there's no linear correlation. Anything positive is different degrees of correlation. So let's look at actually. So I already have a Scala session open. I'm going to log out of that. And then start my Spark session. I allocated a little bit more memory here for the executor, as you can see. So there are prettier ways to do this. You can actually put this in a Scala script and then run it. I just wanted to make sure that everybody can see the different steps here. This is going to take about 5 minutes. Again, this is not vector. This is Spark, so you cannot expect it to be as fast as vector. In vector, it ran in 5 seconds. This is going to take a little bit of time because it's actually calculating the correlation against the different variables over there. So if you want to try this out, you can always contact us for a valid version of vector. And the connectors are all available. You can download it and try this for yourself. Yes?
Is that the community edition that you can download?
You can download the community edition. You can also get an eval copy of the enterprise edition if you contact us. It's like a 15-day eval copy that we can 60.
How do you handle unstructured data?
In vector?
Yes.
Okay, vector basically is a structured database. It's still is going to expect data to be structured. You have to decide the layout of the table beforehand. Right now, we don't offer unstructured data support. There is something there in the roadmap. We're going to be offering that very soon. But as of now, it still expects columns and rows, and you have to decide which data type in advance. Say that again, sorry.
The question was, are you running vector?
Actually, this is a single node vector. It's running on Windows. It's not the scale-out version. It's running on VM, and it's a single node installation.
Didn't it say 20 cores?
Say that again?
It's not really Hadoop that you write.
Yeah, it is not, but you can very easily run this on Hadoop. If you want to do an eval and you want to
Anything
download
can
it,
be
just on
easily
it.
done, but this is not Hadoop.
This is not Hadoop, yes. But the software is the same. It's just a scale-out version of the same software. That's what it is. And what we wanted to show you here is the power of the industrial strength of vector even on one single node on an operating system like Windows. So if you were to do this on Hadoop with a scale-out architecture, it's going to be really fast. So we deliberately chose a smaller
You said that already.
So blast is not loading, does that mean that your numerical computations are a lot slower?
Sorry.
It says the blast, basically when you algebra substitute that is not loading, does that mean that your computations are a lot slower? Is that what it means?
Spark just seems to have a lot of warning messages because some of the versions, some of the code that I have used probably uses deprecated classes or deprecated code. So it does, come up with a lot of warnings. So there you go. It basically printed the correlation values right here. Again, this was slow. I'm very, very sorry about that. This is not vector, so I'm not going to apologize for it. It's Spark. But here's what we did. We basically pulled data out of vector, which is blazingly fast, and we put it into Spark, and we have basically run a machine library function in there to get the data out. I think you had a question.
Was it the same instrument running on SQL, the previous query that you ran?
Yes.
So was it the same correlation being done in just an SQL simple? But that was faster.
No,
But that was
that was actually not the correlation. That was just the data that was required for calculating.
So now we are going to run it on.
And I actually already ran it, and these are the results right here.
This part, right?
Yes.
So that X100 engine that you have, right, that queries the data in Hadoop, can you run any type of SQL queries, or is there a limitation on the type of SQL queries you can run?
No, you can run SQL.
Any SQL queries, including credentials and everything?
Exactly.
Like,
The API is exactly the same, what you would do for, so when you scale out, you're just going to, you don't have to really do any kind of,
Because Hive has a lot of limitations. Are you not interfacing with Hive for that? Take Oracle and replace it with Vector, it's the same thing.
So the question was, can we run standard SQL against the version of Vector that's running in Hadoop? And the answer is yes. It's SQL 2003 core with the analytics extensions, including cube, rollup, grouping sets, analytic windowing functions. So the standard SQL is what we've embraced, which means that any knowledge that you have of SQL that you've gained over your career will just work with Vector and Hadoop. The comment was made that in Hive you have to rework things because they've got a special implementation, or they've done things that are non-standard. Same is true with Impala, and that's not true of our product. We're standard SQL.
How do you handle transactions?
we are fully asset compliant. So,
Okay, so how do you do that on Hadoop? Because in the distributed environment, there is a well-known theorem that basically says that we can know we have partitions and availability at the same time. How do you handle it?
I'm going to let Emma answer that, and I think that's the secret sauce, because we have the VP of engineering.
Yeah, but secret sauce cannot overcome, theory.
Right. So again, the laws of physics apply, right? So when you commit a transaction within Vector, the results of that transaction, when the commit completes, are available for all subsequent transactions that are run. So there is a slight delay as the, and it's a millisecond delay as the distributed cluster kind of syncs up, but we do have asset compliance on Hadoop. It's not eventual consistency.
But what happens if there is a partition? There is a network partition somewhere in the cluster. Let's say your cluster not one node as you're showing, but let's say 5 nodes. There is a partition somewhere there, with 2 nodes on one side, 3 nodes on the other side. So transaction cannot finish.
So
How,
we
how,
have.
how does it happen in milliseconds if it cannot finish?
So the question is, to paraphrase it, what if you have a distributed environment and the transaction is updating records across the cluster, and you have 2 nodes that are accessible and 3 nodes for some reason are not accessible? Is that what you're saying? And that you commit the transaction, right? So what happens in that case is we use Yarn to determine that some of the nodes in the cluster aren't accessible. The Hadoop file system, HDFS, has written block replicas of that data set onto other nodes within the cluster. So we will go from a 5-node cluster, if 3 nodes fail, and the other 2 nodes will be able to satisfy the query. It's a complex theory.
But it's not about writing into the disk. HDFS is handling writing into the disk. You are in memory processing in 5 nodes. If you are doing it like in cloud.
So we're in memory, but we're backed by a write-ahead log file. So like a traditional transactional database is a write-ahead log file where the updates are mirrored from memory to a disk representation of that. That write-ahead log file then is a process that writes the results of the transactions to the database file. So it's purely ACID compliant. You can pull the plug on the cluster.
We're short on time. Let's take that one offline.
We can take this. We need to get together for a full day with you and go through all of this, right? Any other questions? No?
Are we done? Presentation?
Are you done with presentations?
Oh, okay, wonderful. All right, so we got a drum boy. All right, did everyone have a chance to put their card in that fishbowl? Everyone, yes, last chance? Going once, going twice. Okay, can I ask you to reach in there and just mix it all up? Can I ask you reach in, look the other direction, and pull a card out? All right, grab it, read it out.
Ajit Gangra of IBM.
All right, congratulations.